Hello everyone, welcome to today's lesson on relations. Right, so that's the first half of our unit, right? Relations and functions. And relations is pretty much just how two things are related to each other, right? So same definition in math and English, thankfully. Hey, but in math we have a bunch of different ways we can represent a relationship. Okay, so let's take fruits for example. Right? I can have the name of the fruits and then their corresponding colors. Right? Note that watermelons is both red and green. Okay, and we can also put this into a mapping notation. Right? So this is saying apple relates to red, banana relates to yellow, watermelon relates to red and green, blueberry relates to blue. Right? So that's what a mapping notation is, and this right here is a table. Okay, and now most importantly, we can always put relations into ordered pairs. Right? And remember from last time, ordered pairs is x comma y. So, but this can apply to any relation, right? We can say apple comma red and banana comma yellow. Oh, watermelon comma red again, but also watermelon comma green. Making sure we have enough space. And then blueberry comma blue. Okay, so that's ordered pairs. Cool, let me scooch this over here. Right, so we can represent any relation we want with tables, mapping notations, ordered pairs, and there's a bunch of other things we can use as well. Right, so which means that a relation is literally just a set of ordered pairs. Even one ordered pair counts as a relation. If you get something like, I don't know, 3 comma 5, right, that means 3 relates to the 5. Ordered pairs denote relations. So now, here are the four most important definitions you will hear me talk about a lot. Domain, range, independent, and dependent variables. So the domain is the first set of components, or typically the x values. Whereas range is the second component, or the y values. Right? Which means that the domain for our previous example is apple, banana, watermelon, and blueberry. Right? We do not repeat the domain, so we don't go apple, banana, watermelon, watermelon, blueberry. We just repeat it once. Right? And the range is red, yellow, green, blue. Right? Okay, we don't do repeats. Okay, and then we got independent variables. So that is an arbitrary input. Right, so independent variables are generally for inputs, so independent input. Right, and again, usually the x values. And this means that the dependent is the output. So the dependent depends on the input. Usually the y values. Because it depends on the x values. Alright, so here's a few examples of more ordered or more relations, right? We got this relation here, 2x plus 1. Right, so now we're putting our input, let's say any number can do, say negative 3. Right, when we plug it in, we do negative 3, right, or 2 times the negative 3 plus 1 to get negative 5. That's our output. Right, so input, relation, output. Right, so it works for any number, right, for the input. You can do 0, if the input is 0, 2 times 0 plus 1 gets us the output of 1. Input of 2, 2 times 2 plus 1 gets output of 5. Right, and now with those three relations, again, just completely random numbers, we could have picked any number, we can put them into ordered pairs. Right, the input is x, so negative 3. Negative 5 is the output. That's our ordered pair. 0 and 11. 0, comma 11. 2 and 5. 2, comma 5. Right, of course, that can be a table as well. Right, we got x values up here and then y values down here in a table. We can have as a mapping notation again. Right, as you can see here, that whenever we have x on the left and y on the right, we essentially have the domain mapping onto the range. And last we can graph for that as well. There's no numbers here, but this is roughly what it would look like. Right, 0, 1's here, 2, 5's there, negative 3, negative 5's over there. Okay, but with that being said, right, let's practice some domain range here. Like I said, this is one of the most important parts of graphs. We always want to know the domain range, right? Just so we know what values are we looking at. Okay, so starting off with the first one, right, the domain here. Right, the domain here is all the x values. So we have a 1, a -3, and a 4. Right, generally, we write it in numerical order. So -3 first, 1, and 4. Right, 1, -3, 4. That's the domain. And then the range. Right, this might look a bit familiar. Right, those squiggly brackets. Right, so range again. So the y values right here. We go smallest to biggest. So -2, 2, 5. Those squiggly brackets might look familiar because this is set notation, right? We briefly talked about it in our little intro. I think unit 2. All right, next, of course, doesn't really matter how many there are. We can just lift them all out. Right? So the domain here. We got -3, 1, 0, 3. Luckily, it's in alpha or in numerical order already. Whoops, not 2, 3. Range. Once again, the y, so the 4, 0, 2, 2. Notice how we got 2 twice. Right? But we only read it once, because we do not repeat. So it's just 0, 2, 4, right? It's not 2, 2, just 2 by itself. Right, if you ever feel lazy to write the domain, you can just write x if you want. Right, domain is just x anyways. So here we have 2, 1, 3, 1. So 1, 2, 3. Range 1, 0, 3, 4. So 0, 1, 3, 4. Right, so this is how we use set notation, right? The domain -3, 3, 2, 4. And numerical order -3, 2, 3, 4. Range numerical order -1, 3, 0. So -1, 0, 3. Okay, there we go. Right, but now we can actually look at graphs as well. Right, because from earlier, right, we have to separate all the numbers by comma, right? Because it's telling us that it's telling us exactly that we have this point, this point, this point, this point. So those are the only x values here, right? They're separated by comma. It's one point at a time. However, if we look at those graphs here, right, it's not just one point anymore. It's a whole line, right? And the line pretty much says that every single number within the line counts as a domain, right? So what we can do is, okay, let's look at the domain here. What can the x values be? Right? X value, okay, of course, x can be 0. It could be 1, right? 1's right here. X is 2 is here. Oh, sorry. X2 here. X3 is here, right? But also can also be like 0.5, right? 0.5 is around here-ish. Like 0.1, around here-ish. Right? So there's an actual infinite number of numbers. And now we notice here that for all the x values, right, it pretty much goes on to infinity, right? Because starting at 0 here, when x is 0, the graph is here-ish. Every single number after that is on this line, right? Because this arrow here on the line indicates that this line goes on forever. It doesn't just like stop at one point. Right? So whenever we see arrows, it always means the line goes on infinitely. Okay, so in this case, if the line goes on infinitely, that means every single x value is gonna be hit, right? Both positive and negative. So we say x is all real numbers. It's a fancier way of saying just it's infinite. Every single number you can think of. If you want, you can write it like this. Right? So this is the proper set notation for all real numbers. This pretty much means this symbol here means includes. So x includes all real numbers. Right? Again, that's the symbol we use for real numbers. How about the y? How about the domain? Okay, the domain is, the range. Right, the range is a little bit more obvious. Right, so what can y value not be? Right, we know that y value can be here, -2. Right, but as you can see here, there's no graph line below this -2 point. Right, the graph only goes up. Right, as you can see here from the arrows, the graph only goes up from the -2, but nothing ever gets below -2. So we can say, okay, y is just big or equal to -2. And that's it. Right? So y can be any number as long as it's bigger or equal to -2. Right? Because as you can see here, nothing gets below this line. Okay, let's take this circle here. What's the domain? Right? What x values does it cover? We can see the domain here, the x values. Right? It does not go past the 2, nor does it go past the -2. Right? X is contained between the 2 and the -2. Right? We do not have a circle that goes out here. And the circle is contained within the 2 and the -2. So which means that x is then smaller or equal to 2 and bigger or equal to -2. Okay, so that's what the domain is. Right? It's enclosed between -2 and 2. Right? So that's why it's bigger than -2. It's bigger than this, but smaller than 2. Smaller than this. Okay, the range is similar. Right, we have it's being sandwiched by 0 here and a y value of 3. So as you can imagine, the range is just y bigger or equal to 0, smaller or equal to 3. Okay, that's the range. Okay, let me jot that down. So that's 2 and -2 here. This is contained at 3 and 0 for the y. How about here? Now there's no longer a line. We are back to points again. Right, look at the points here. Right, the domain where x is possible is when x is 0, x is 1, 2, and 3. Right, so now if we were looking at points, then we have to go back to using commas. Right, again, we do not use bigger or equal to signs here because those are separate points. That's why we need commas. And the range, same idea, right? We got y equals to 3 here, y equals to 2 here, y equals to 1, and then y equals to 0. So it's just 0, 1, 2, 3. Okay, so when there's no line, we use commas. How about this graph here? Right, so now we have a new idea or new concept here, which is a hollow circle. Right, so as you can imagine, if the circle is dotted in, right, then that means we include this point. But now here in this case, the circle is hollowed out, right, which means that this point here, this point of -2, -2, is not included in this graph. Right? But as you can see here, this line stretches out to infinity, which means that all the x values, right, all the x values must be bigger than this point, right? It goes on forever that way. Right? So it's bigger than -2. And same as y, right? Every single y value is going to be bigger than this point, right? Because it goes up infinitely. So as long as it's bigger than -2, that's including the graph. Right? So you can see that's the only difference here. When the dot is hollowed out, then that means we do not include this point. So we do not have equal to. It's just strictly bigger. Right? Here's a better way to visualize this in our next example. So take this graph here. Right? You can see that it's enclosed by x between x equals to 2 and x equals -2. Right? Except I lied. it doesn't actually include a 2 and -2. Right? So even though the line gets to this point, right, this point itself is hollowed out, which means that it actually doesn't include the point of x equals to 2. So x is sandwiched between the 2 and -2, right? So that's the same. But the only difference here is that instead of it being equal to, right, bigger or similar and equal to, right, because it's hollow, it's just greater than or smaller than, that's it. And with a range, it's even more tricky, because we know here, there's no hollow dot here. So we assume that the line here will get to this point of y equals to 3. But down here, at -3, right here, let's jot it down here. So it's sandwiched between 3 and -3. Right? Because this is the highest point, that's the lowest point. But we notice here, -3, right, is actually not one of the points. Right? This point here does not include -3. Which means that y is still, right, it's still smaller than 3 because of course it's a solid line, so it includes the 3, but it is not equal to -3. So we have this, right? Y is bigger than -3 because this dot is not included, but smaller than 3 by itself. Oh, sorry, smaller or equal to. Okay, tricky stuff. Last example. What is this? Okay, let's check the domain here. Right, what's the smallest x can be? Right, notice here that the smallest point of x is right here at -3. Right, because after here, after it curves back around, it goes on to the right infinitely. Which means that in this example, as long as x is bigger or equal to -3, that's part of the domain. Right, again, this is equal to here, because we do not have hollow dots, right? This is included. How about the range? Right, what's the highest y can be? Highest y is at the value of 2 right here, right? Because this arrow is not going infinitely this way, it's gonna keep decreasing. And again, this is a solid dot right here. So y is bigger or smaller or equal to 2. Okay, but that's pretty much it for domain and range. Right? So this lesson, right, we establish that relations is pretty much just ordered pairs. Right? And the domain is the x value. So domain and independent variable always refer to the x value. Range and dependent always refer to the y value. And knowing that, we can find the domain and range of all the graphs and relations. Okay, so this takes a lot of practice to get used to, right? But at the end of the day, we pretty much look for what's the smallest x, what's the biggest x. Boom, encased. If x is every single number, then we can just say, oh, it's all real numbers. We can indicate it with the symbol here. Right? So with that being said, good luck practicing.